All right, so picture this. You're finally getting ready for that amazing trip overseas. Could be, you know, Kyoto, maybe Berlin for work, or just backpacking somewhere incredible. You get everything lined up, passport, tickets, the whole itinerary. You're all set. Then you look at your phone charger, maybe your hair dryer, that electric shaver you can't live without, and that little voice pops into your head around, will this actually work over there?
Oh, yeah,
And
right.
for most of us, yeah, we immediately think about the plug, like is it the weird three-prong kind? Or maybe voltage is at 110 or 220, so we grab our adapters, maybe a hefty converter, feeling pretty smart, like we've cracked the code. But here's the twist, and this is really what we're diving into today. What if there's this other crucial factor, something most of us totally miss? An invisible thing that could actually mess up your electronics, maybe even make them unsafe. It's not the plug, not just the voltage. It's something else.
You've hit the nail on the head. That hidden factor. It's called frequency. And that's our whole focus for this deep dive, getting into the, honestly, pretty fascinating world of electrical frequency around the globe. Our mission, really, for you listening, is to take this thing that sounds super technical, maybe a bit intimidating, and make it, well, easy to get, practical. We want you to walk away feeling truly well-informed so your gadgets stay safe and sound on your travels. We'll look at the basics, the surprising history behind it all, and what it actually means for your stuff. We're aiming for that beginner-friendly vibe, making sure it clicks.
Right, making it click. And to guide us through all this electrical stuff, we're leaning on some really great material, specifically bits from 18tosha.txt, which itself draws from Ajahn book, And Osho the Key. The title basically means electricity for absolute beginners, so you know we're keeping it clear and accessible. That's the goal. Okay, let's jump in. Okay, let's unpack this. Frequency. When we're talking about the electricity from the wall socket, you know, the power we use for, well, everything. Well, what is frequency? Seriously, for someone like me, maybe not an electrical engineer, what does that word actually mean here? It sounds abstract, but you're saying it's super important.
It's absolutely the right place to start, because understanding frequency. That's key to why your hairdryer might act weird in another country. So the power from your wall outlet, that's almost always alternating current, AC. And to really get frequency, we need to quickly touch on AC itself. See, it's not like DC direct current from a battery where the electricity just flows one way, positive to negative, steady as she goes. AC. Well, it alternates. Think of it less like a steady river, more like the tide coming in and going out. With AC, the direction, the polarity, it doesn't just go one way. It flips back and forth really, really fast, many times every second. It's not a constant push. It's more like a super fast wiggle, positive, negative, and that constant flipping. That's actually why AC is so good for sending power over long distances. It made building national power grids possible, which was, a game changer. So frequency, it's just counting how many times that complete back and forth flip, that full cycle, happens in 1 single second. It's not about how much power is flowing, like voltage or amps. Right. It's about the speed of that flipping. The rate of the wiggle, if you like. There's a good analogy in the source material. Think of a pendulum, swinging side to side. One full swing, left to the right, and back to the left again. That's one cycle. Frequency just measures how many of those full swings happen in 1 second. And the unit we use, that's hertz, written as hertz. So if you hear 60 hertz, it literally means 60 of those full back and forth cycles are happening every second. Right here in South Korea, for instance, our AC power flips direction 60 times every second. That's why our standard is 60 hertz, 60 hertz. It's this incredibly quick, invisible rhythm humming away in your walls right now.
60 times a second. Wow, okay, that's actually hard to wrap my head around. That speed is something else. So if I'm getting this right, it's not just about the raw power or if the plug fits. It's this invisible beat, this electrical tempo. And our devices are kind of designed to, dance to a specific beat. And if the music changes, they get confused. So is frequency the second big thing we absolutely need to check right alongside voltage when we go abroad?
You've got it perfectly. That dance analogy is pretty close to reality for a lot of electronics. If your device expects that 60 hertz rhythm and the outlet's giving it 50 hertz, things do get out of sync. It's fundamental. Just as vital as voltage, especially for anything with a motor or precise timing. Get the rhythm wrong and you risk performance issues, shorter lifespan, maybe even serious damage. It's the kind of detail that, could easily turn a fun trip into a headache.
Okay, that makes a lot of sense now. So Korea's 60 hertz. If this is so critical, does that mean there are dozens of different frequencies all over the world? Is every country marching to its own electrical drum beat? Because that sounds like a complete nightmare for travelers.
Thankfully, no, it's not quite that wild. Which is, yes, a huge relief if you travel a lot. Despite all the countries out there, the world basically settled on just 2 main frequencies. 50 hertz and 60 hertz. It's pretty much one or the other in most places. That simplifies things massively for you. No need to worry about like 53 hertz or 67 hertz. It's usually 50 or 60.
Phew, okay. That is a relief. Much easier checklist. But, that makes me wonder, why just those two? And why the split? Why didn't everyone just agree on one? There must be a story there, right? It feels like more than just engineers picking a number. What's the history?
Oh, there's definitely a story. And you're right, it's not random at all. It's fascinating, actually. It goes way back to the early days of electricity, late 1800s, early 1900s. When countries were first setting up their power grids, the choice of frequency often came down to who they were getting their technology from. It was heavily influenced by the big industrial players of the time, mainly German and American companies, and their respective engineering preferences and, yeah, their economic influence. You remember the War of the Currents, Edison pushing DC, Tesla and Westinghouse championing AC. Well, even after AC won out for transmission, the specific type of AC system wasn't totally standardized immediately. Different engineers, different companies were tweaking things. So countries that leaned towards technology developed in Germany, companies like AEG, they generally adopted systems designed around 50 hertz. German engineering was really influential, especially across Europe and parts of Africa and Asia. So as they helped build grids, 50 hertz spread with them. It was often about who sold them the first generators. And on the other side, you have the US. Companies like Westinghouse and General Electric, building on Tesla's work, they optimized their systems for 60 hertz. As American industry and economic power grew, especially in North and South America and parts of Asia too, 60 hertz became their standard. So trade deals, technological partnerships, even sort of cultural alignment played a role. The map of 50 hertz and 60 hertz countries today, it's basically a historical echo of those early industrial rivalries and influences. It's amazing, really.
Wow, that's incredible. Like an invisible layer of history baked into our power outlets.
Yeah.
A tech legacy. So, okay, following that logic, how did South Korea land on 60 hertz? Was it a direct U.S. connection from the start?
It's a perfect example, actually. South Korea's story ties right into this. The very first electric generator in Korea. It was installed back in 1887 at Gyeongbokgung Palace, a huge step in modernization. And guess who made that generator?
Let me guess. An American company.
Bingo. General Electric, GE, from the United States. So that foundational choice, using American tech right at the beginning, set the standard. South Korea adopted 60 hertz from day one, and we've stuck with it ever since. It's a direct line back to that specific historical moment and that GE generator.
That's genuinely fascinating. A great bit of trivia. Okay, so it sounds like most countries chose a side, 50 or 60, and built their grid around it. But I remember reading in the source, Japan is different. Kind of throws a wrench in the works.
Yeah.
What's the story there? That sounds tricky for travelers.
Japan. Yes, Japan is the big exception, the really interesting outlier. While pretty much everyone else picked one frequency for the whole country, Japan actually uses both 50 hertz and 60 hertz. Right now. Today.
Both.
Oh.
At the same time. How does that even work?
It's another historical quirk. Basically, when Japan was electrifying, different regions gained their equipment from different sources, and they never standardized it nationally. So the power companies in the east, around Tokyo, the Kanto region, they mostly installed 50 hertz systems, often from German suppliers. But the companies in the west, around Osaka and Kyoto, the Kansai region, they went with 60 hertz systems, often American-made. And they just stayed that way. The two grids developed independently and weren't fully interconnected in a way that unified the frequency. So yeah, if you travel from Tokyo to Osaka, you're crossing a frequency line. Your 50 hertz appliance might work fine in Tokyo, but could struggle or break in Osaka, and vice versa.
That's nuts. So you actually need to know which part of Japan you're in to know if your stuff will work right.
Pretty much, yes. Or you need devices specifically designed for Japan that can handle both, which many modern ones are, but older stuff, or things not bought in Japan. You have to be careful. It's a vital travel tip for Japan.
Absolutely wild. Adds a whole new planning wrinkle. Okay, so apart from that very unique Japanese situation, what's the general rule elsewhere?
It really highlights the issue, doesn't it? But yes, outside of Japan's dual system, the general rule holds. Most countries stick to one single frequency nationwide. It does mean, though, that checking that frequency spec before you travel is just as important as checking the voltage, maybe even more so because frequency converters for everyday use are basically non-existent. You can easily convert voltage, but changing frequency, that's a whole different, much harder problem.
Okay, we've got the what, the why, the history, even the weird Japan situation. Now let's get to the really crucial part for everyone listening. If I take my hairdryer, my laptop, whatever, from Korea 60 hertz land to, say, Europe 50 hertz land or the other way around. What actually happens? Is it just going to run a bit slow, or are we talking sparks and smoke? What's the real consequence? The brass tacks.
This is exactly why frequency isn't just some abstract number. It can have very real, sometimes very damaging effects. Even that seemingly small difference between 50 Hz and 60 Hz can significantly change how a device operates. It's definitely not minor. And yes, in some cases, it can lead to more than just sluggishness. It can cause actual failure. Where you see the biggest, most immediate impact is with electric motors. Think about things like vacuum cleaners, washing machines, refrigerators, fans, blenders. Many of these use what are called induction motors. And the way these motors work makes them inherently sensitive to the input frequency. Basically, the AC creates a spinning magnetic field inside the motor, and the rotating part, the rotor, tries to chase that field. The speed of that magnetic field spin is directly tied to the AC frequency. So imagine the motor is designed for 60 Hz. That magnetic field is spinning at a certain speed. If you feed it 50 Hz power, the field spins slower. About 17% slower, actually. The rotor, trying to keep up, just can't reach its design speed. So yes, a 60 Hz motor on 50 Hz power runs slower. And the opposite is true, too. A 50 Hz motor on 60 Hz power will try to run faster than it's supposed to. It's a direct relationship. Speed is proportional to frequency for these motors.
Right, okay, so my powerful 60 Hz vacuum would literally have less suction power on 50 Hz. And my washing machine might spin slower, maybe not clean as well, take longer. That sounds annoying, but maybe not disastrous.
It's definitely annoying, and the performance drop is real. But it's often worse than just being slow. When a motor runs slower than intended on lower frequency, it tends to draw more electrical current to try and compensate to get the torque it needs.
Right.
More current means more heat builds up in the motor windings. And heat is the enemy of electronics. It degrades insulation, increases wear and tear. For things like refrigerators or washing machines, this inefficiency and extra heat can seriously shorten the motor's lifespan or even cause it to overheat and burn out completely. Let me just touch on the why, very simply. Inside motors, there's something called inductive reactance. Think of it like frequency-dependent resistance. Lower frequency means lower reactance. Lower reactance lets more current flow for the same voltage. More current equals more heat. Specifically, heat is proportional to the square of the current, so even a small increase in current means significantly more heat. This extra heat can melt insulation, cause shorts, basically fry the motor. It's not just about speed, it's about electrical stress. So yeah, using the wrong frequency, especially for motor-driven appliances, directly impacts lifespan and efficiency. Overheating, excessive current draw, premature bearing wear, it can lead to damage, sometimes pretty quickly. The source specifically calls out those common household items with induction motors: vacuum cleaners, refrigerators, washing machines, also things like blenders and fans. Even some old-school electric clocks that use the AC frequency to keep time would run fast or slow. These are the things you really need to be careful with. A frequency mismatch here isn't just a minor inconvenience. It can be destructive or even dangerous.
Okay, message received loud and clear. Big appliances, anything with a powerful motor, that frequency check is non-negotiable before plugging it in abroad. Forget just getting it to turn on. You need to make sure it works right, works safely, and doesn't cook itself from the inside out. Really drives home that idea of looking beyond the plug.
Precisely. Now, the good news is technology has evolved. Many modern electronics, especially things like phone chargers, laptop power supplies, camera chargers, they're often dual use, or Yunuyung Jipum, as the source calls it. They're designed internally to handle a range of voltages, AND, both 50 Hz and 60 Hz frequencies. You'll often see it printed right on the label. Input, 100 240V, 50-60 Hz. That 50-60 Hz is your magic ticket. It means it's built to adapt. These usually have smart power supplies inside. But, and this is the really important but, if your device doesn't explicitly say 50-60 Hz, if it only lists 50 Hz or just 60 Hz, or maybe only one voltage, then you absolutely must check the frequency of your destination country. That little label is crucial. Don't ever assume universality, especially with motors or older gear.
Got it. So let's nail this down for everyone listening. When you're packing for that trip, check voltage and check frequency. Every time. Unless the device itself clearly states it's cool with both 50 and 60 Hz, you need to match it up. Otherwise, you risk frying your stuff, having it fail, or worse. It really is about understanding that hidden electrical rhythm. This whole conversation really opens up a new way of thinking about electricity. We've talked frequency, voltage, but it makes me wonder about electricity itself. You know how we talk about product quality? Like, is a car reliable? Is a phone well built? Does electricity have quality too? What actually makes for a good electrical supply? Beyond just, being there and having the right specs.
That's a fantastic question, and it connects everything perfectly. Yes, absolutely. Electricity, just like any service we rely on, has definite quality standards. Utility companies obsess over this stuff, and for us as users, it's vital. These standards are often boiled down to what are called the three elements of electrical quality. They define how good, how reliable our power supply really is. Element number one is blackout duration, or this is pretty straightforward. How often does the power go out and for how long? A high-quality supply means very, very few interruptions throughout the year. Think about it, constant flickering, frequent outages. It would be chaos. Your computer crashing, food spoiling, traffic lights failing. High quality means consistency, reliability, the lights staying on virtually all the time. It's fundamental for homes, businesses, hospitals, everything.
Yeah, okay, that makes total sense. Constant power outages would be awful. Reliability is key. So minimal blackout time equals high quality. What's number two?
The second element is voltage maintenance rate, or gongyo. This is about stability. How steady is the voltage? Ideally, if you're supposed to get 220 V, you get 220 V, not 210 V 1 minute and 230 V the next. Those fluctuations, called sags or swells, are bad news. Lights might flicker, motors can strain and overheat, sensitive electronics like computers or TVs can get stressed, leading to errors or premature failure. Their internal power supplies aren't designed for wild swings. So, maintaining a stable voltage, keeping it within a very tight tolerance of the target level, is crucial for device health and performance. It's about precision.
Right. Consistency again. Not just having power, but having the right level of power steadily. Okay, and the third one. I have a feeling I know where this is going.
You guessed it. The third element ties directly back to our main topic today. Frequency maintenance rate, or just like voltage, the frequency also needs to be incredibly stable. It can't just wander around. Whether the standard is 50 hertz or 60 hertz, it needs to stay locked onto that target with very, very little deviation. Power grids are complex balancing acts. If the frequency started dipping to 59 hertz, spiking to 61 hertz, it would cause all sorts of problems. You already talked about motors running at the wrong speed, but think bigger. Electric clocks would lose or gain time. Industrial processes relying on precise timing could fail. The entire power grid relies on generators spinning in perfect synchrony, locked to that frequency. If it drifts too much, you risk cascading failures, widespread blackouts. So keeping that frequency stable, maintaining that precise 50 or 60 cycles per second rhythm across the entire grid is absolutely critical for reliable operation. It's a huge engineering challenge, actually. So there you have it, the trifecta of electrical quality: minimal blackouts, continuous supply, stable voltage, and stable frequency. These three together ensure that the power flowing into our homes and businesses is reliable, consistent, and safe for all the devices that depend on it. It's the foundation of our modern tech-driven world.
That really puts it all together. So these aren't just abstract numbers for the power company. They directly affect how well our stuff works, how long it lasts, if it's safe. It makes you appreciate that seemingly simple outlet on the wall a whole lot more. It's not just power. It's precisely controlled. High-quality power, thanks to that stable frequency rhythm. Understanding frequency isn't just for travel. It's about understanding the very pulse of our modern lives. Hashtag outro. All right, let's do a quick wrap-up of the key things to take away from this deep dive. Actionable insights for you. First off, traveling. Check both voltage and D frequency every time, unless the label clearly says 50-60 hertz, match it to your destination. Super important. Second, remember the big split the world runs mostly on 50 hertz? Think Europe, much of Asia, Africa, influenced by German tech, or 60 hertz, America's Korea, Japan, West, influenced by US tech. History in your outlet. Third, Korea is 60 hertz, thanks to that very first GE generator back in 1887 at Gyeongbokgung Palace. Cool bit of history. Fourth, Japan is the odd one out, uses both. 50 hertz around Tokyo, Kanto, 60 hertz around Osaka, Kansai. Crucial if you're traveling there. Fifth, frequency mismatch is bad news, especially for motors, vacuums, fridges, washing machines. They can run wrong, overheat, wear out fast, or just break. Check for that dual-use label. And finally, frequency stability isn't just a travel issue. It's a core part of electrical quality, along with steady voltage and minimal blackouts. It's that invisible, steady rhythm keeping everything running smoothly.
Exactly. And maybe a final thought to leave you with: the next time you plug something in, anything at all, maybe just pause for a second. Think about that invisible energy flow, that hidden rhythm, 50 or 60 beats per second, powering your device. It's kind of amazing, isn't it, how history, physics, engineering all come together in that simple act. And it makes you wonder, maybe, What other invisible rhythms, what other fundamental things that underpin our daily lives are we just taking completely for granted?
That's a great question to ponder. Really makes you think. So maybe go grab your phone charger right now. Seriously, look at the fine print. Does it say 50, 60 hertz? Think of it as a tiny passport for your electronics. And take a moment to appreciate that steady, reliable power humming away delivered right to you. Until our next deep dive, keep exploring.